welcome to the deep dive. Today, we're plunging into a subject you might not immediately connect with the man who brought us, white rabbits and mad tea parties.
That's right. We're exploring the surprisingly rigorous world of logic, specifically through the unique lens of Lewis Carroll or Charles Dodson, if you prefer his academic name.
And the source material is his book, Symbolic Logic.
Yeah, primarily excerpts from that.
So our mission today is to unpack what Carroll was trying to do with this book, this system he built, and maybe why studying logic, especially his version, might be more, well, delightful and useful than you might think.
Definitely. Get ready to see some foundational ideas about clear thinking, but presented with Carroll's, characteristic precision, his wit, and sometimes, a gentle jab at his contemporaries.
Okay, let's dig into this stack of sources and see what nuggets of wisdom Carroll has for us.
Let's do it.
One of the first things that really jumps out is how Carroll frames logic. He doesn't see it as some dry academic chore, does he?
Not at all. He calls it a fascinating art, and he actually promises it will add a very large item to your stock of mental delights, which is quite a claim for a logic book.
It really is. He clearly saw real pleasure in thinking clearly. But, okay, while he promises delight, he's also incredibly strict about how you should learn from his book. He lays down some pretty firm rules.
Oh, absolutely non-negotiable rules.
Rule number 1, don't just dip into it like a novel. He says reading a scientific book out of order is, and I quote, sheer insanity.
Yeah, no skipping ahead to see if the lovers get married or the wicked cousin gets foiled or, my favorite, if the rich uncle in India dies exactly at the right moment.
That one feels very specific.
Doesn't it? But it makes his point. Logic builds. You can't just jump in anywhere.
So you have to go chapter by chapter, understand it thoroughly before moving on. Don't leave unsolved difficulties behind you.
He warns that if you do, your puzzlement getting worse and worse. Sounds like he might have dealt with a few confused students, maybe?
Seems likely. But he does offer this very Carrollian piece of advice for when you get stuck.
Yes. The secret weapon for puzzling topics, logic, or anything else. Talking it over aloud to yourself.
Talking to yourself. Isn't that, well, usually considered a sign of something else?
He anticipates that. He says you can explain things so clearly to oneself. But the real kicker, he argues, is that one is so patient with oneself, one never gets irritated at one's own stupidity.
Okay, I have to admit that's actually pretty insightful.
Yeah.
And kind of comforting. We are our own most forgiving teachers, I guess.
Right. So if you follow his rules, maybe chat with yourself a bit, what's the payoff?
He promises 2 big things. First, the habit of arranging your ideas properly, structuring your own thoughts.
And second, something he thinks is more valuable than all. The power to spot fallacies and to tear to pieces the flimsy, illogical arguments you run into.
And he says you'll find them everywhere. Books, newspapers, speeches, even sermons. He really urges the reader. Try it. He sees this as a vital skill for just getting through life.
He even makes these odd comparisons, like Euclid's famous 47th proposition, mere child's play compared to defining a straight line.
Wow.
And the 5 liars problem, trifles, light as air, he says, next to the really deep question, what is a thing?
What is a thing? Yeah, okay, I can see how that gets philosophical fast. So, with the rule set and the promise made, how does he actually start building this logical system? What are the Lego bricks?
He starts super basic, things and their attributes. And the core idea is a class, just a collection of things that share one or more attributes.
Like the class of red apples, attribute red, attribute appleness.
Precisely. Then you can divide classes. That's division, like dividing books into bound and unbound.
Or by the first letter, he mentions.
Right. And a really important type of division is dichotomy, splitting a class into 2 totally opposite parts. X and not X. He uses the little prime symbol X for not X.
So everything's either X or not X, like awake or not awake, no middle ground.
Exactly. And this leads into naming and defining things. A name just refers to a thing using some of its attributes, but a definition is more specific. It names something in a species, a smaller group, by pointing to its genus, the bigger group it's in, and its differentia, the thing that makes it special within that genus.
Okay. Can you give us one of his examples?
Sure. A treasure is defined as a valuable thing. Thing is the genus. Valuable is the differentia.
Simple enough.
Or men are animals having 2 hands and 2 feet. Genus, animals, differentia. Having 2 hands and 2 feet.
And what about unique things? Like London.
For London, he uses the town which has 4 million inhabitants. The signals it's unique, a class with just one member, basically.
Got it. So things, attributes, classes, definitions, the basic concepts. How does he start making statements about these things, building arguments?
Right, that's where propositions come in. This is the language of his logic. Carroll insists on putting every logical statement into a standard, normal form.
A normal form, what does that look like?
It's always got 4 parts, in order. 1, the sign of quantity that some, no, or all. 2, the name of the subject class. 3, the copula, always are. And 4, the name of the predicate class.
Quantity, subject, are predicate, always. So you have to kind of force everyday sentences into that.
Pretty much, yeah. It involves translation. Like, my carriage will meet you at the station. That becomes, all my carriages are things that will meet you at the station.
Okay, a bit clunky, maybe, but I see the structure. He notes my carriage is a class of 1 there. What about something like, happy is the man who doesn't know toothache? The subject isn't first.
Good example. You have to identify the subject class first. Here it's men who do not know what toothache means. So it becomes, all men who do not know what toothache means are happy men.
Ah, okay. You rearrange it to fit the form. And a negative one.
Like, no lambs are accustomed to smoke cigars. That fits more easily. No lambs are animals accustomed to smoke cigars.
Okay, I'm starting to see how this standardization works. Now, he makes a really interesting point about propositions starting with all. This feels like a key Carroll insight.
It really is. Carroll argues quite strongly that any proposition starting with all, what logicians sometimes call an A proposition, like all bankers are rich men, isn't just one statement. It's actually a double proposition.
Double, meaning what exactly?
Meaning it's equivalent to 2 separate statements rolled into one. First, some bankers are rich men, and second, no bankers are poor men.
Whoa, so saying all X or Y automatically means 1, that some X do exist and are Y, and 2, that no X exists that are not Y.
Exactly. And Carroll stresses this is a fact within his system. It's not just some arbitrary rule about whether bankers really exist or not. And this whole idea leads straight into a major disagreement he had with the mainstream logic of his time.
Ah, the existential import debate. He seems pretty passionate about this.
He is. He's very clear that the rules he sets down in his book about whether a statement implies the reality or existence of its terms, well, they're arbitrary choices he made for his system, rules chosen because they work consistently within that system.
Okay, arbitrary but consistent. And his chosen rule is?
His rule is that propositions starting with some or all, the I and A types, do imply that their subject class actually exists.
So some unicorns are white means unicorns exist, all dodos are extinct means dodos exist, or did.
Right, but propositions starting with no, the E type, like no dragons breathe fire, do not imply existence for either the subject or the predicate in his system.
And he contrasts this with the logicians,
Yeah.
the textbook writers, right? He seems to think they're a bit inconsistent on this.
He definitely does. He says they take a more humble position, handling the word are with bated breath. His critique is that they sort of fudge it, sometimes assuming existence for all and some, sometimes not, depending on what works, and he argues this leads to contradictions.
And he has a very specific example of how their approach breaks a standard logical process.
Yes, he targets conversion, especially for I propositions, some X or Y. The standard rule is simple. If some X or Y is true, then some Y or X must also be true. Seems obvious.
Okay, some dogs are friendly. Converts to some friendly things are dogs. Makes sense. But the logicians mess this up.
According to Carroll, yes, because of their wishy-washy approach to existence. He uses this great example of a boys' school. Imagine there are rules about which classes study French, Greek, and Latin. Now suppose the first class, the one meant to study all 3, is actually empty. No boys are in it.
Okay, a hypothetical empty class.
Right. The school rule says the top 2 boys in each class get prizes. Now, in the logician system, where they might not assume the class exists, they could say the statement, some boys in the first class will receive prizes, is true.
How is it true if the class is empty?
They'd read it conditionally. If there were any boys in the first class, then some of them would receive prizes. Based on the school rule, that conditional statement is true, even with an empty class.
Okay, I follow. The conditional holds. So statement 1 is true for them.
Exactly. Now, apply the standard conversion rule. Convert some boys in the first class are boys who will receive prizes into Some boys who will receive prizes are boys in the first class.
Okay, standard flip.
But now think about what that converted statement means in their system. It would mean something like, if there were any boys about to get prizes, then some of them would be in the first class. But we know the first class is empty, so that statement has to be false.
Oh. So the original statement is true in their system, but its standard conversion is false.
Yeah.
That is a problem.
It's a major problem. Carroll calls it a new flaw in the theory and uses the image of a cricket batsman knocking down his own wicket. His point is that his clear rule, some and all, always imply existence, avoids this paradox entirely. Conversion works cleanly in a system. He argues there are really only two consistent ways to handle existence, and his way is just more practical.
That's a really sharp critique. It shows he was seriously engaging with the foundations. Okay, so to make all this less abstract, he introduces diagrams, right?
He does, and they're brilliant. Diagrams and counters to visualize everything. He starts with the biliteral diagram, basically a square chopped into 4 smaller cells.
And this represents the 4 possibilities for 2 attributes, like X and Y.
Exactly. Imagine the top half is X, the bottom is not X, the left half is Y, the right is not Y. So the 4 cells are X top left, XY top right, XY bottom left, and XY bottom right. Every possibility covered.
That visual mapping makes sense and goes further than just 2 attributes.
Oh yeah. He shows a triliteral diagram for X, Y, and Z that has 8 cells, and he even mentions diagrams for up to 10 attributes. That would be 124 cells.
Wow, imagine trying to draw that. So you have the diagram space. How do you mark statements on it?
With counters, a red counter in a cell means this cell is occupied, meaning your statement says at least one thing exists with that specific combination of attributes.
And a gray counter.
Gray means this cell is empty. No things exist with that combination.
And wasn't there one for uncertainty? When you know something's in a general area, but not exactly where?
Yes. That's a red counter placed right on a dividing line, a partition. It means the combined area on both sides is occupied, but you don't know which specific cell holds the thing. Carroll borrows that phrase from his ingenious American cousins for this, sitting on the fence.
Ah, that's perfect. So you can map propositions. Some X's exist is a red counter in the X cell. No X or Y is a gray counter in the X cell because that combination is empty.
Exactly. And the real magic happens when you combine these to solve arguments. Which brings us to syllogisms.
Right, the classic 3-liner, 2 premises leading to a conclusion.
Yeah, the goal is find the conclusion that has to be true if the premises are true. Carroll often translates concrete propositions like some soldiers are brave into abstract form like some M are X to work with the system.
And you use the diagrams and counters for this.
That's the visual method. You take your 2 premises, put their counters on the diagram, whatever the diagram must show after both premises are represented. Well, that's your conclusion. It reveals which cells have to be occupied or empty.
Give us his famous, slightly weird example.
Ah, the cats and chickens. Premise 1, all cats understand French. Premise 2, some chickens are cats. What's the conclusion?
Okay, yes, that's that one.
Let M cats, X understands French, Y chickens. Premise 1 is all M are X. Premise 2 is some Y or M. You'd put counters on the diagram for these. All M are X means the MX cell, cats who don't speak French, gets a gray counter, it's empty. Some Y are M means the wine cell, chickens that are cats, gets a red counter, it's occupied.
Okay, got the counters placed.
Now look at the diagram. Those 2 placements together force you to conclude that the YX cell, chickens that understand French, must be occupied. You'll have a red counter there. So the conclusion is some Y are X.
Or some chickens understand French.
Exactly. And he adds that little joke about this maybe being true on Mars, where chickens could be nursery governesses, who you could also eat later. Classic Carroll.
It definitely makes it memorable. He also mentions another way, without diagrams.
Yeah, the method of subscripts, it's more like algebra. You use notation like XO for no X or M. Subscript 0 means empty, and ICY1 for some X or Y. Subscript 1 means occupied. It works, but maybe less intuitive than seeing it on the diagram.
Okay, so that handles simple arguments. What about longer, more complicated chains of logic?
That's where SOAR rates come in. A SOAR rate is basically a string of propositions linked together. You figure out conclusions step by step until you get one final complete conclusion from all the starting premises.
And again, he thought the logicians were a bit limited here.
Very limited, yeah. He felt they only dealt with really simple, basic SOAR rates forms. He wanted methods to tackle much more complex chains of reasoning.
So what were his methods for these bigger problems?
He gives 2 main ones. The method of separate syllogisms is just what it sounds like. Solve pairs, Take the conclusion, pair it with another premise, repeat. It works, but it can be slow.
And the other one.
The method of underscoring. This uses the subscript notation again. It's a faster way to track how premises link together and eliminate the middle terms until you connect the very first subject to the very last predicate.
He gives that incredibly convoluted example, doesn't he? With policeman, the cook, long hair, poets, Amos Judd, prison, cold mutton, and cousins.
Yes. It sounds completely absurd, like something from Wonderland. But he shows how you translate all those statements into abstract subscript form, apply the underscoring method, and systematically derive the single conclusion linking, say, the cook and the cousins or whatever it was. It really shows the power of having a system to cut through that kind of complexity.
It does feel like a practical tool for untangling messy real-world arguments, potentially. Okay, before we wrap up, let's touch on a few more characteristic Carroll quirks. The five liars paradox. How did he handle that?
Ah, yeah, that's a classic logic puzzle that can get really tangled in self-reference. Carroll's solution is pretty ingenious. He sidesteps the whole "this statement is false" issue by translating it into an analogy about condiments.
Condiments. Salt and mustard.
Exactly. Telling two truths becomes like taking both salt and mustard. Telling two lies is taking neither, and telling a truth and a lie is taking only one. By shifting it to concrete actions, he avoids the subtle and mysterious difficulties of self-referential propositions altogether. It's a clever logical reframing.
That is brilliant. Very lateral thinking. He also had strong opinions about negative attributes, didn't he?
He did. He accused the logicians of having a perfectly morbid dread of negative attributes. They like to say things like, John is not in the house, treating is not as the verb. Carroll insisted it was more logical and useful to say, John is not in the house.
Treating not in the house as the attribute, the predicate.
Exactly. An affirmative statement, John is, about a negative attribute. He felt this allowed his system to handle many more types of valid arguments, making it more powerful. It's a subtle point about logical structure, but important for his system.
And finally, he even invented words.
He did. He needed technical terms, of course, but he also coined the plural sorites for sorites. And he defended it. He said, look, if series is accepted for series, then sorites should be fine too, applying logic even to his own grammar.
It really shows he was actively building something, refining it.
Absolutely. And this whole deep dive into Carroll's logic, it isn't just, historical trivia or amusing oddities.
No, definitely not. Think about the flood of information, the arguments, the claims you encounter every single day, online, in the news, at work.
Carroll's system, or at least the thinking behind it, gives you tools. Defining terms clearly, putting arguments into a standard form to see their structure, visualizing relationships, and maybe most importantly, spotting the weak spots, the fallacies.
So whether you're trying to understand a complicated report or figure out if an article's argument actually holds water or even just make sense of a confusing conversation, these logic skills seem incredibly relevant.
They really empower you to engage critically with all that information rather than just letting it wash over you.
So we've journeyed through Lewis Carroll's unique logical world, from his stern advice on how to read his book through the basics of classes and propositions, his rather controversial take on existential import, those cool visual diagrams and counters, and all the way to the syllogisms and the complex sorites chains.
We've seen his careful method, his practical tips, his playful but sharp jabs at the establishment logicians, and his, well, sometimes quirky solutions.
And it's just fascinating, isn't it? How the mind that gave us the sheer imaginative chaos of Wonderland could also build such a rigorous, structured system for pure thought. It kind of proves logic doesn't have to be boring.
Not at all. It can be creative, precise, even humorous.
So what does this mean for you listening now? Well, maybe the next time you hear an argument that sounds convincing, but
Yeah.
something feels off.
Yeah.
Maybe you'll mentally try to sketch a little biliteral diagram or check if someone's sitting on the fence with an assumption.
It gives you that moment to pause, to analyze, to maybe ask for clarification instead of just nodding along.
Okay, here's a final thought to chew on. If learning these logical tools helps us become better, more critical consumers of information, better at spotting weak arguments, what does that suggest about the responsibility of people who create arguments and present information, especially to audiences who might not have these tools quite so sharp?